Okay, so we're going to use our shell method practice here. We're going to find the volume of the region bound by y equals x, y equals 2x, and y equals 2, and rotate it around the x-axis. So it says we're going to rotate this thing around the x-axis. So generally that formula would be, if we're using a shell, if we use a disc or a washer, it'd be different. But if we decide to use the shell, it'll be the volume equals 2 pi from the bounds of a to b, a radius times a height dy. So a, b, r, and h all need to be in terms of y. So let's start graphing this to see what it looks like. So y equals x, that's a straight line with a slope of 1. So it goes through, 0, 0, 1, 1, 2, 2, 3, 3. It goes down through the negative side as well. I don't know if we need it, but this would be our y equals x. Okay. And then the next one, y equals 2x. That would be a straight line but with a slope of 2. So a little bit steeper. Y equals 2x. And then y equals 2 comes across here. So the region we're looking at is a little triangular region in the first quadrant. Okay, so it would mirror over into the fourth quadrant when you actually put it out here. Bad drawing. But it would be a circular region coming around and hitting the bottom as well. So let's see what we can do here. Remember, we want everything in terms of y. So we first of all need our bounds. Our volume is going to be 2 pi, and we need an upper and a lower bound. Well, the bounds will be from 0 to 2 based off of y over here. So the smallest radius when we go around the x-axis here, the smallest, lowest bound will be 0, and it will go out to 2. So that will be from 0 to 2. The radius, so we're basically drawing off of a center point, and we're drawing out to some point, and we're rotating that. So that radius will actually be a y value. Okay, so that radius will be a y value. Okay. So r equals y. Now the height will be from whatever the far line is back to the closer line. So this right here will be the h, whereas the other part will be the r. So let's just kind of change a little bit in color there as I've drawn it. So the radius is y, but the height will be the distance between the two lines. Now, one thing we got to do here is make sure we write it in terms of y. So the far line is y equals x. So x equals just y. And the other one is y equals 2x. Well, we need to get x by itself. So that would be x equals 1/2 y. So we'll subtract that closer one. So that height will be y minus 1/2 y, or 1/2 y. So we'll come over here and put that in. So what do we got here? We got the volume being 2 pi and the integral from 0 to 2 of the radius y and the height 1/2 y dy. So that's not hard to clean up a little bit before we go in. So 2 pi from 0 to 2 of 1/2 y squared, and then we'll actually do our integration. So y cubed it will go up to, and we'll divide by 3, so it'll be 1/6 y cubed. Ooh, let me not forget my 2 pi out there. So I've still got the 2 pi hanging out front. And it'll be times 1/6 y cubed from 0 to 2. So y squared goes up to y cubed. I divide by that 3, so putting it in the bottom with a 2, yes. So another cleanup, if we like, this is pi over 3 y cubed from 0 to 2. So we'll let y equal 2. So we will have pi over 3 times 8, and then we'll subtract letting y equal 0. So we'll have pi over 3 times 0. That'll go away, so it looks like we'll have 8 pi over 3. The main thing here, not to mess up, is it's kind of easy since both these, all these functions are given as y equals, y equals, y equals, to put things in terms of x by accident. And it's not forbidden to use a washer here, but usually the reason the shell is chosen over a washer is if you look at the way the triangle is drawn out. So let me come over to the side and draw the triangle. The triangular region looks similar to this, and you're going to want to rotate it around the x-axis. So the reason the washer is a little bit rougher is because when you go to do that outer and inner radius, at one spot the y equals 2x is an outer radius, and in another spot the y equals 2 is a outer radius. So you would kind of have to split the integral into two parts wherever that outer radius is. So you'd have one integral from 0 to, I think that is 1, and then you have another integral from 1 to 2. Same inner radius, the y equals x, but two different outer radiuses. So that's just a little bit more information why the shell would be a little bit easier to do here than the washer.